Formation of ring structure in sugars. Sugars have a tendency to form the ring structure. Ring structure is very stable structure. So more than 4 carbon sugars, they form the ring structure. Before learn about how the ring structures is formed, let's learn about the formation of hemiacetal and hemiketal. Hemiacetal and hemiketal formation. Hemiacetal formation where aldehyde molecule reacts with an alcohol. So this is your aldehyde, this is your alcohol. Hemiacetal is formed. So what happens? This R1C, this breaks from here, RCH OR2, and this is OH. This is known as hemiacetal, and this can be converted into acetal. This will react with the another molecule of alcohol, R3OH, and the water will be come out, and then the acetal is formed, R1CHOR2, and this O will, this H and OH will go off, and here OR3, and this is known as acetal. So this is your ketone. React with alcohol, then hemiketals are formed. This will break from here. This is hemiketal, and this will be converted into ketal. When it reacts with another molecule of alcohol, molecule will be released and ketal will be formed. So what will happen? R1C R2 OR3, and this bond will break here, and here OR4, and this water molecule will be released, and this is known as ketal. So on this concept, the sugar forms the ring structure. In case of sugars, this is your glucose molecule. So how the ring structure is formed in the sugar? Each molecule have a tendency to form the stable structure. So the ring structure is very stable structure. The chair form is the most stable form. The aldehyde group of the first will react with the alcohol of the fifth carbon to form the ring structure. Glucose generally form the 6-membered ring. So we'll start writing from the carbon 1. Why the ring structure is formed? Why first carbon react with the fifth carbon? Because they arrange themselves like this. So the first carbon react with the fifth carbon. Because of the steric hindrance, if they are too close, the structure is not stable. This is the first carbon. I'll write H double bond O. This is your aldehyde group. This is the first carbon. Then this is the second carbon C and H and OH. So this is the Fisher projection formula. So the left side group will be on the top and the right side group will be on the lower side. So we'll write it like this. This is your sixth carbon. This is your fifth carbon. And they arrange like this. Here, the fifth carbon, this is the OH will go here. H will be here. This is the C. And then the ring structure will be formed. So this is a pyranose ring. This H will shift here, and then this H will come on to this. So H, OH, and then O is here, and H, OH, OH, H, H, OH, CH2, OH, and H. So the ring is formed. This carbon, the first carbon, is known as anomeric carbon. This is the formation of hemiacetal. If this is known as alpha glucose, why? Because the OH group is on the downside. If the OH group is on the top side, on the upside, then it is known as beta glucose. So on the anomeric carbon, if OH group is on the downside, that means alpha. If OH group is on the upside, that means it is beta glucose. This is beta glucose. This is the Haworth projection formula because carbon is a tetrahedral molecule. So generally they form the chair form and it is hard to draw the structure. So Haworth projected this ring structure. So I can show you with the model. This is the pyranose ring. This is your oxygen molecule and this is the structure of glucose molecule. The red one are showing the hydrogen group and the white ones are the OH groups. And this is your CH2OH. Green one is your CH2OH. And this broad line showing the ring is towards you. So generally when we draw the structure, we draw the bold lines. That means this side of the ring is towards you, like the second and the third carbon is towards you and the fifth and the oxygen molecule is on the back side. So in the Fisher projection formula, the groups are on the left side are on the top and the groups on the right side are on the bottom. So this is your first carbon. First carbon is the anomeric carbon and this is the way of presentation and this is known as Haworth projection formula. So alpha and beta glucose, they have a tendency to rotate the plane polarized light. If you dissolve the pure alpha glucose into the water, there is a continuous change in their specific rotation. The pure alpha glucose specific rotation is 112 degree. It will continuously change till to the 52.5 degree. Similarly, if you take the pure beta glucose into the water and dissolve it, its specific rotation is 19 degree. And if you dissolve it, this is also going to continuously change to the 52.5 degree. The property of the glucose to change the specific rotation till they reach to the equilibrium is known as mutarotation. So at equilibrium, alpha glucose will be 34% and beta glucose will be 64% and open chain form 0.003%. So this, the most stable structure is the beta glucose. I hope you like my video. Thank you. Please comment and subscribe my channel if you like it. And if you have any question, please send me via my email tripsh11@gmail.com. My email address is on my front page. Thank you. Bye.